this video, we're going to talk about how we can solve some logarithmic inequalities. So what is a logarithmic inequality? It's an inequality, or they are inequalities that involve logarithms of variable expressions. So in order for us to solve these, we can use one of two ways. One, we can follow this logarithmic property of inequality, which states that if b, x, and y are positive real numbers with b greater than 1, then log base b of x is greater than log base b of y if and only if x is greater than y. And also, log base b of x is less than log base b of y if and only if x is less than y. So that is one way we can use that logarithmic property of inequality. But also, we can solve by exponentiating each side of the equation, right? So we can raise basically the initial, and I wrote equation in here, but we know this needs to be inequality, right? Okay, so for inequality, we can take both sides of the inequality, make those exponents to the same base, right? Because in that case, then our exponents would have to follow that same inequality symbol in order for the entire inequality to be true, okay? So we're going to look at 5 examples in this video. Our first one is log of x is less than or equal to 4. So when I exponentiate, I'm trying to exponentiate to the same base that my logarithm is already being applied to, if that makes sense. So in this case, log of x is just log base 10 of x. So I can exponentiate by giving both sides a base of 10. Okay, so we have 10 to the log base 10 of x is less than or equal to 10 to the 4th power. So now I know 10 to the log base 10, that will cancel. So it just gives me x is less than or equal to, and then we can do 10 to the 4th power, and that's going to give us 10,000. Okay, so now one thing we need to remember with logs, with inequalities. Remember our logs, when we graph them, they're inverses of exponential functions. Well, exponential functions, we know that the range is greater than 0 because our graph approaches but does not intersect the x-axis. But as soon as we change that to a logarithmic function, we now reflect it over the line y equals x, and so now our x and y, our domain and range, are now switched. And so now our domain, our x values, we approach the y-axis, but we don't intersect it. So we only have values for x that are greater than 0. So we do have to add this over here. Okay, so x is less than or equal to 10,000, but it also is greater than 0. Okay, so that's one thing we have to add in there. All right, number 2, we have ln of x is greater than or equal to 3. So I can exponentiate both sides by giving both sides a base of e, because that's going to cancel out my ln. So now we have x is greater than or equal to e to the 3rd power. So we can do that in our calculator, e cubed, and that's going to be approximately 20.086. 20.086. All right. Number 3, log base 4 of x is less than 4. So let's exponentiate each side with a base of 4. So now 4 to the log base 4 is going to cancel out. So we have x is less than or equal to, and we do 4 to the 4th power, and we get 256. Now, once again, we have a less than symbol. So x is less than 256, but remember, we can't be less than 0. So we still need to add in here the fact that we are greater than 0. Okay? So x is between 0 and 256. All right. Last 2, we have some operations that we need to undo that are happening to our log or to our common log and our natural log. So for number 4, let's start off by subtracting 6. So now we have negative 3 times log base 5 of x is less than or equal to 3. And now let's divide both sides by negative 3. Now keep in mind, when we are working with inequalities and we divide by a negative or multiply by a negative, it does still flip our inequality symbol. So now we have log base 5 of x is greater than or equal to negative 1. Now we can exponentiate both sides. 5 to the log base 5 of x is greater than or equal to 5 to the negative 1st. So now that's going to give me the fact that x is greater than or equal to 1 over 5 to the 1st power, or 1 over 5. Okay, so x is greater than or equal to 1/5. All right, 5. 2 ln of x minus 1 is greater than 4. So let's add 1 to both sides. So 2 ln of x is greater than 5. Let's divide both sides by 2 to get ln of x is greater than 5 over 2. Now we can exponentiate by giving both sides a base of e. And now we have x is greater than e to the 5 halves. So e to the 5 halves. And that's going to give me x is greater than 12.182. okay? And that is how we can solve some logarithmic inequalities.